I'm going to talk about the no-go area service. Let me first illustrate this service with the accident that took place in September 2013 with a small chemical tanker Ovid grounded on the Varn bank. The tanker had a draft of 7.9 meters and she grounded on Varn bank with a minimum draft some 2 meters and on a 1.4 falling tide. And the strange thing with this accident, we could spend the whole day talking about that because there was many strange things, but look at this picture here. You can see the planned route of the Ovis went straight over the bank, and of course she grounded. No surprise to that. You can also see this is a paper chart. It's 300 years of cartographic generalization at its peak. You have the areas, the depth less than 10 meters in a darker blue color, the depths between less than 20 meters in a light blue color to really enhance the dangerous area for shipping. Let's look at the ECDIS on board what the ECDIS look like on board the Ovis. This is the snapshot from the Accident Investigation Board. This is the ECDIS. Here you see the Varn bank. And you can see one of the good things about ECDIS was that you should be able to choose which safety contour should be enhanced depending on your own depth. Now, why would a chemical tanker with a draft of about 8 meters choose the 30-meter safety contour if they intend to actually venture into this area? You can see a planned track actually going here. We don't know that. What we do know is that the default factory setting for this ECDIS, particular ECDIS, was actually 30 meters. So there is something in implying that maybe they never changed it, ever. And by that doing away with some kind of warning. Another strange thing was that the alarm port from the ECDIS system was never activated, ever. So there was never any grounding alarm from this thing. So what I want to say with this is that in the ECDIS there are many good things, but we also created some kind of very complex technology that people out there seems not to be able to cope with and therefore just skip it. And we get some kind of chart system that is working less well than it should be. So with this as a background, and here you can see 2 other snippets from the accident report. This is the Dover Strait with the 20-meter safety contour and with the 30-meter contour. And you can see that the whole southern path is visually not possible to go. So the no-go area is supposed to be a simplified way of producing a warning areas for depth that you should not go into, and it takes into consideration the tidal situation, your draft, and your own customized underkeel clearance allowance that maybe your charterer would want to apply onto you. And this is a technical description on how we want to do that, and a suggestion for how we, in this service, try to visualize it on the EPD. So we tested this system, and we were actually allowed to use. So one of the drawbacks with the safety contour is that you can only use safety contours that is already in the ENC system in the S57 or something. So you would have the 10, the 20, the 30 meters safety contour. You could not get the 15 or 13 meter safety contour. If you in our system, the way we developed it, has access to the usually classified depth database, which was allowed by the Danish Hydrographic Service. We were allowed to actually access data, request data for a specific depth and a specific time of a tidal situation. So that would allow us to make sort of safety contours or no-go areas for 15.6 meters, for instance. And if you read about the Torres Strait underkeel clearance system, you know that every decimeter calculates in millions of dollars worth of cargo that can go into these areas to make shipping really efficient. So we tested this in the Humber estuary, the test bed there. Humber is one of the biggest ports in England. 25% of all the shipping goes to this area in Grimsby, Immingham and Hull. You can see it's a difficult area. with a lot of sandbanks, and the sandbanks are actually shifting. The ENCs are not really to trust in a sense. So for that reason, they are doing constantly surveying in the Humber area. And if you go into this humber.com website, you can actually get the latest chart updates that they're having a vessel going almost constantly in the area. And what you can get then is you can get a PDF file that looks like this. And if you look close to it, you will have the measurements straight out of the boat. So this could be maybe 1 or 2 weeks old. So it's much, much better data than you actually have in the ENC. The problem is that you have this in one computer as a PDF file, and you have your ECDIS with your ship positioning in another computer. And actually, how do you do that? Well, the answer is, of course, you don't do that. So this is something that the pilot is looking into when they're sitting at home in the chamber and try to blend it into the mental model of what's actually happening in the river. But luckily for our project, we had access to this database. So with the help of the UK HO, we had a database with all these data, and we tried to get that into the EPD that you can see here. Unfortunately, it was a little cumbersome. So in this area, for instance, you have 2 channels into passing the Spurnhead VTS. Depending on the tidal situation, they were sometimes accessible for certain vessels, sometimes not. What you would do is, in the EPD, the way we implemented this service, you would request a no-go area, you would decide for a certain time, a certain time duration, and you will set your ships for a certain ship draft and a certain wanted underkeel clearance, and you would request a no-go area, and the system will chew on this for quite some time because there's a huge number of data crunching to be done underneath here, and you will get this no-go area that will show you that this area for your ship at this particular point in time with the tidal situation is closed. You cannot go that way, but however you can take this channel up here. So that's the point of it. And of course the idea was that in a perfect system this will all be done automatically in front of your vessel. Sort of if you look 1 hour ahead, you will also look 1 hour into the future of the tidal situation. But technically we were not able to do that right at the moment. But you at least see the idea here, and this is the way the things change, and this is from the EPD shore. This is what the VTS saw on their screen, so they can also use that for planning purposes for large deep draft ships coming into the area. We tested that during the 4-day full mission bridge simulator study that we did together with the intended and suggested routes that Anders talked about before coffee, and it was the scenarios that you saw on the slideshow were actually the main thing with the route exchange, but this was as a benefit for the side of that. And we tested it with 11 professional British, Swedish and Danish pilots, support master and VTS operators, all with experience from this area. And you can see the demography of the people there. Highly experienced people tested this. So if we look onto the observations and feedback we got from this, we could say on a conceptual level that the pilots and the officers, they liked it because it facilitated communication between the pilot VTS and the ship officers. So for instance, it would bring the captain into the game in a different way. Otherwise the captain would stand beside the pilot. The pilot was to have the mental image of where was the possibilities to go. Now the captain could also see in the ECDIS how the situation, the tidal situation, the no-go areas were actually in. So it facilitated communication, and it also gave the VTS and pilot extra confidence that they hadn't made any mistakes in their envisioning of the tidal situation. On a procedure level, there was a lesson workload for the VTS and pilot, partly due to they didn't have to explain a lot of times to the rest of the bridge team how the situation were and why they took a certain channel and a certain turn. There was also a lessening of radio traffic on the VHF constantly asking for the gauge values at different points in the Humber River, because everybody could then, with the system, see what the situation was looked like. Of course, then on a functional level, they all thought it was too complicated, too many clicks to get this information. They needed to have it automatically along the route, and they also thought they needed to have alarms for, and talking about alarms, we should not do that, that's entirely other things, but they wanted to have some kind of alarms, it goes off if you go into these areas. Complicated, too many clicks. So that was the feedback. So in general, we got very good feedback for it, and looking at the survey, we asked them, what is your opinion about the tested no-go area concept? And we got mainly good comments on it. One person didn't quite know what he thought. You think a similar? Would you think a similar concept would come reality in the future? And most of them did. And I also asked them the question about professional acceptance. What is your professional opinion about the system tested? And you can see that we got an average score between acceptable and very acceptable for this service. So, thank you very much.